Hey there, guys. This is second video on integrating natural log functions. So I want to take this time now to do some problems that might be a little bit different when we're doing natural log functions. You might need to do a little bit of creative thinking, or you might actually have to do some long division. What? Long division of polynomials? Yep. So when you integrate a fraction where the degree of the numerator is greater than or equal to the degree of the denominator. So, like x squared over x plus 2, or x squared, like I have here, x squared minus 4x plus 2 over x squared plus 2, then you're going to need to use long division to simplify this guy out, okay? So I'm going to, right here on this one, and I'm going to go and zoom in a little bit on this in just a second, as soon as I can get my pen working here. Recall that the antiderivative, the antiderivative 1 over x dx is equal to ln of absolute value of x. Okay, so remember that plus c. Okay, so don't forget that. That's what you kind of have to remember here. So first things first, I can't quite do this. If I take the derivative of x squared, that's going to be 2x. It's not up on top, so I can't do a reverse chain rule. You look at this and there's really not much we can do. So, but they are the same power. So let's go and use long division. So we're going to do x squared plus 2. And we're going to go into x squared minus 4x plus 2. So here's how we do this long division again. We need this to be a 1. So 1 times x squared is x squared. 1 times 2 is 2. Oops, that goes over here. And then we're going to subtract them. Okay, then we're going to get negative 4x, and we're going to get negative 4x. So then this turns into 1, and that's the remainder, right? So it's 1 minus, because it's a negative, 1 minus 4x over x squared plus 2. So that's our long division. So we're going to change this to the integral of 1 minus 4x over x squared plus 2 dx. Now look at, what's the derivative of 2x? Well, the derivative, I was ahead of myself there. Sorry, guys. What's the derivative of x squared? 2x. Woo, yay, 2x. So that's the derivative is 2x. So what I'm going to do is I'm going to split this apart here. Minus 2 integral of 2x over x squared plus 2 dx. And notice here that what I did was I took and I split it apart. Oh, man, it's going kind of slow here. I split it apart so that way the derivative of x squared will be 2x, and I have my hook on here. I can use my reverse chain rule. So then this is going to be x minus 2 ln absolute value of x plus 2 plus c. Don't forget your plus c. All right, so there you go. There's that one. Let's take a look at a couple more. That might be a little interesting here. It's my example 6. Let's integrate ln x over x dx. So what I'm going to do for this one is I know that there's got to be a derivative in here somewhere, right? What's the derivative of ln x? The derivative of ln x is 1 over x. Wow, look at that. So if I rewrote this as ln x times 1 over x dx. And just for the heck of it, I'm going to put to the 1 power. What's the derivative of ln x? 1 over x dx. So this right here actually is our hook. And this is a reverse power rule for integration. So I'm going to end up with ln x squared over 2 plus c. That's kind of a tricky one, huh? Okay, let's take a look at another one here. See, I don't know if I can move this over all the way, and I think I'm going to be in the screen here. Let's see if I can zoom in. Do that. Okay. So what am I going to do here? Well, what's the derivative? This looks like a reverse chain rule. What's the derivative of 2 minus ln x? The derivative of 2 minus ln x is negative 1 over x. Well, look at, I already have the 1 over x. I just need a negative here. So I'm going to put a negative there and a negative there, and then this right here becomes my hook. So then I'm going to have, let's rewrite this as negative integral of negative 1 over x times 2 minus ln x to the negative 3. This might make it a little easier to see. So then this is my hook right here, right? Sorry, there's a fly in my face. Jeez, man. These flies are vicious here. Negative, I'm going to add 1 to that. It's going to be a negative 2. So I'm going to have 2 minus ln x to the negative 2 divided by negative 2 plus c. Okay, these negatives can both turn positive. There's our answer. All right? All right, let's take a look at one more for this video, and then I will save the rest for another video. Okay, what do we got going here? Remember when we have a square root in the denominator, we might want to use U-Substitution. Okay, so let's go ahead and make u equal to square. Well, not u, but you know this u. U as in letter U. You got it. That time I really meant you. You got it. All right, so this is u squared equals x. 2u du equals dx. All right, so then we're going to make our substitution in here. So we're going to have the integral of 1 over u minus 1, and dx is 2u du. Okay, so then what do we got here? Well, notice here that we're going to get integral of 2u over u minus 1. And this has the same power, so we're going to need to do, what do we say we do when that happens? We're going to need to do long division. Okay, so u minus 1 into 2u is 2. Which is going to give me 2u minus 2. Subtract these out. And that's going to give me a 2. So this is plus 2 over u minus 1. All right, so we're going to have the integral of 2 plus 2 over u minus 1 du. And notice here, this is pretty easy. That's just going to be 2 ln. So we're going to have 2u plus 2 ln of absolute value of u minus 1 plus c. And of course, we cannot leave it like that. So we're going to make sure we put back our x and substitute that back in here. So we're going to have 2 root x plus 2 ln of absolute value of root x minus 1 plus c. And then we're done. All right. Okay, there you go. There's some not so straightforward ln natural log integrals for you. Catch you later. Bye.